My name is Satyan Devadoss. I'm a professor of mathematics and computer science at the University of San Diego. So I'm a math professor, and my work focuses around shape. So I love to study how shape can be framed, how shape can be measured, how shape can be looked at, how shape can be understood. And when you think of mathematics, to me mathematics is all about how do you make sense of patterns and structures of things. So you can make patterns and structures of numbers. You get prime numbers and the numbers used for encryption and data. You can make patterns and structures of functions like sine function and cosine function, useful for engineering and 1,000 other things, or money, useful for transactions. Or you can make patterns and structures of pictures, and that's what I do. I study pictures. So angles and triangles could be very simpler things you might have learned earlier, but even those really simple things turn out to have really deep, complicated, beautiful things as we get older. So that's what I love. One of the things I'm in love with is not just mathematics. My title actually is Professor of Applied Mathematics. And that word applied has two meanings. There's the 20th century meaning. And 20th century meaning is applications has always been what Boeing would want. Let's use mathematics for an engineer to build airplane design or submarine structures or build buildings. So mathematics has been applied using the tools of sines and cosines and functions for engineers and scientists and physicists. So Einstein uses the mathematics, and that's applied math. But this amazing shift has happened in the 21st century. In 21st century, applied mathematics is no longer about subject. It's not about differential equations or calculus. It turns out every math you could ever imagine is applied math. So if you care about numbers, it turns out that almost everywhere that numbers are multiplied together and factored into pieces is how data is encrypted when you swipe your Visa card. So the National Security Agency, NSA, they hire mostly math PhDs who are number theorists. Number theory turns out to be useful for people anywhere in the world today. If you care about issues of chance and probability, like how often do I get heads or tails in a simple coin toss or rolling dice, it turns out that's the foundation of how you do prediction analysis for business. You want to model these things because you have so much data coming in that you can't get anything 100% right. So now data is almost going to be approximated. You'd be happy to be 95% sure, 90% sure something's going to work because you have terabytes of data coming to you per second. So now all of a sudden things that were known for probability turns out to be applied. If you care about patterns of how molecules are organized and the structures and shapes of a Rubik's Cube, for example, turns out that's the foundation for quantum mechanics issues and foundations for chemistry. So turns out almost every mathematical idea that you can think of turns out to be applied, even from number theoretical stuff. And what I care about is shape. And a revolution happened related recently to the kind of shape I care about, which is not geometric shape, which talks about spheres and angles, but topological shape. And topology just means take off your glasses. If you take your glasses off, how does the world look? It looks fuzzy. And I mean, you roughly get the idea of the shape, but you don't get it perfectly. And it turns out at Stanford, there's a professor named Gunnar Carlson who I worked with. And he was one of the founders of this field called topological data analysis. So what he does is he looks at data, and he takes off his glasses, and he sees the data approximately in a fuzzy way. And he's able to tell you what the overall shape of the data is in a fuzzy setting. Not in a perfect angular measurement setting, but in a fuzzy setting. And that helps a lot because most of the data that we get have noise in it, right? No data that's coming to us is perfect. A lot of people, when they fill out their forms and you're watching Netflix and you're giving Netflix data, if you're giving data from Amazon or Apple, you don't fill out all the fields, so they don't know everything about you. There's all these holes missing. And that data has noise because you might maybe fill one or two things incorrectly. So the fact you could take off your glasses and get a rough approximation of what's really going on is beautiful. So using topological data analysis, you could immediately tell whether you're normal or have type 1 or type 2 diabetes really quickly. You can quickly see that there are these three branches going on and you're going to fit in one of those things. You don't need to know the exact geometry, but that rough topology is really good. So everything's applied. That's why I love it. So one thing that I did with my students recently is I wanted to find patterns and structures in beer. So San Diego, where I'm at the University of San Diego, is really known for their for their beer. It's one of the #1 craft brewery markets in the world. I think there are about 160 different brewers here. And so we went to one of the oldest brewers here, it's the San Diego Brewing Company, and we talked to the brewmaster. And we said, can you tell us what makes a beer? Instead of the labels of Pilsner or IPA or ales, what is it that makes a beer special? And the brewmaster said, actually, if you take any beer in the world, if you rip the label off, you basically have about 15 to 25 characteristics of what makes a beer, including things like original gravity, final gravity, pounds of hops, temperature that goes in, temperature coming out. And he gave me a list of about 20. And he said, any beer in the world can be broken up into these 20 pieces. And they have different weights. Sometimes the alcohol content actually matters a lot, sometimes it doesn't. And so what we did was we took the data of 21 different beers that they had. They gave me the data for each of their pieces. This is called basically the beer genetics of what a beer is. And we put it in some sense, to like a gene sequencing machine. And it spit out a family tree of how these 21 beers are related to one another. And so to me, that's how I think of applying mathematics. You take real-world problems, real-world interesting questions that are out there and how things can be related to one another, maybe through the lens of biology and genetics, and then you use the mathematical tools to extract that and say, here's something else you can do with it. Now, a word of warning for me is that this genetic tree of how the beers are related to one another, it is not more powerful or more amazing than anything the brewmaster already knows. So I want to be really clear that math is not here to trump what reality is about. It's just here to partner with the world, to talk with them about it. It might be a different way of framing something that people haven't seen before, but to say that somehow math now with this beer genetic tree is the ultimate truth with a capital T is something that's very worrisome, and you have to be careful. I think if you think about almost any other discipline, they struggle with their own notions of truth and notions of what it means to be right. And math just comes along and shares its perspective. One of the things I've found over the years when every time I travel is people are honored to be with me because I'm a mathematician. Somehow they think I'm smarter than them because of the fact that I have a math credential. This is really interesting to me. If I'm in a plane and somebody's sitting in the middle and I'm sitting on one side of them as a mathematician, and the world's greatest Nobel laureate poet who's on the other side, or one of the most amazing artists who exists in the world today sitting on the other side, people usually, it feels like, turns to them and say, oh, you're an artist, that's great, but this is a mathematician. He really understands what it means to be smart. No matter how smart you are, he really gets it. And they use smart like with a capital S, right? Somehow I have the full truth with a capital T in my hand. And I find that really dangerous. I think, having grown up in India, there's a spectrum of how smart somebody is. And I thought it was an Indian thing till I came to the States and I realized it's the same thing everywhere. On one side is a mathematician, and then next to them are the physicists and the biologists and the chemists, and then over here the sort of the social scientists, right? They're science-y, but not really. Economists, psychology, and then you get into historians, and eventually you get into linguistic scholars and languages. And way over on the other side are the artists. And most students think, oh, I'm not a scientist, I don't think this way, I'm not this smart, so I'm actually going to be on the art side. I think that spectrum is universal. But at the same time, the spectrum hides something. It hides the level of complexity. I think to me, the mathematician is really productive and it's really good and it has great output is because she is dealing with something that's not complicated. The fact that you have something called a quadratic formula means that a formula can answer whatever you're thinking about. It's crazy, right? If I'm talking to my wife and I realize that she's not happy with how I acted the day before, there's no wife formula to plug in, because to hang out with another human, to deal with them as a person, to love them, to forgive them, to take care of them as a human is far more complicated than a formula or an equation. So what do we do as math, right? We take an idea of beer, complicated as it could be, about the smell of a beer, about the taste of a beer, about the social construct of what it means to be human and drink a beer, and we boil it down into about 20 variables, and then we say, oh, here's the family tree of beer. But that's a pathetically silly slice of the complication of what beer really is. I think what happens as you move down the spectrum is you're dealing with things that get more and more complicated, and thus you can't say that much about it. A historian is dealing with a far harder question than a mathematician. They can't answer it in an easy way because the question's harder, right? They can't nail it down as simple as we can because there's no formula for it. They have their own tools of measuring truth and their own tools of measuring smartness, but the thing they're asking is a complicated thing. And an artist is actually trying to describe things that can't even be expressed in words. In fact, they need images to even get to the kind of things that we can speak in English. And in math and physics, we can speak it in formulas, so that's triviality. I always say that we can put somebody on the moon because putting somebody on the moon is easy. We can't solve race relations, not because the people who study race are not smart, but studying race relations is incredibly hard. It's really hard to talk about equality of men and women in the world today and the Me Too movement that's pushing ahead, because those are incredibly hard questions for us to wrestle with. And how do you bring justice in the world today that people are struggling with? The currency in the world today is science, right? Is quantification and data. A friend of mine studies black pastors in the South, and he's not a Christian, he's not a believer, but he's been interviewing the transformation of the lives of these black pastors in the South for about 20 years. And he's a sociologist, and he wants to know, what does it mean to be wrestling with issues of race and faith? At the same time, one of the biggest narratives as a pastor is this exodus, that God will one day set you free. And it really resonates with the African American community. But what happens if now the pastor of this church is now driving a Lexus? Does that mean that they've already achieved it? Clearly, that's not what the world says. So that's the kind of really deep, sophisticated, in-depth question he's dealing with. But most of the journals that he's submitting his work to keep saying to him, where's the data? And he's saying, this is the data. What it means to be a human is to talk to them and to understand with them. You can't quantify and distill this into a bunch of numbers. That's trivializing the work. So the world is obsessed with truth based on data. And it's dangerous because it's wrong. That's the simple stuff. The thing is, I think that absolutely makes sense if you're in the science world. You should be judged, right, by data and in the sciences. Yeah. But the problem is when you start leaving the world and using the same set of tools. One of my favorite people is Richard Dawkins. I like him because he's truly passionate about what he believes in. And I'd rather have somebody who's passionate and against faith or against God. That's great. I'm glad he's put his chips on the table. But the reason I struggle with him is because he's not trained as a philosopher. He's not trained as a theologian. He's trained as a biologist, as an evolutionary biologist. He's brilliant at what he does. But you can't take those same set of tools and say, now I have enough tools to answer any questions. Stephen Hawking did the same thing when he talked about philosophy being dead. He said philosophy is now dead. Well, that statement is a philosophical statement. So he's using philosophy to talk about philosophy being dead. And he's a brilliant cosmologist. He's a brilliant physicist, one of the greatest who's ever existed. But to say that those weapons in physics can now be used to shoot down other arguments in history and in science and in history and political science and philosophy is dangerous and wrong. I guess what attracts me and what pulls me and makes me think of the Christian faith is not things from a scientific lens. If I think back to what it means to be a mathematician when I was in undergrad or grad school, I don't remember any lectures from a professor that was amazing. I had amazing professors, but I don't remember, oh my gosh, that lecture on triple integrals was just incredible. I don't remember any of that stuff. I usually remember things like, hey, the pizza party we had that night, or the night we played euchre, or the way the girl smelled next to me, or the dance. Okay, who am I getting? I never went to a dance, but you understand what I'm saying. But all of those things is what it means to be humans, is what attracts me and gives me these memories. So the reason I'm attracted to the Christian faith is not because of some scientific slam dunk argument. Of course, if there's a huge tension between what the Christian faith says and the way the world is framed according to the Christian perspective versus the scientific data we have, then we're in trouble. But I don't see that tension at all. In fact, if I'm reading through Scripture or listening to how it's been interpreted, it's usually that that the scripture is not really interested in science. It's not making questions of science. It's answering questions of who we are, why we're here. Why do we feel anger when we watch a movie like 12 Years a Slave, when we want justice to happen in this world? What does it mean to forgive? What does it mean to retaliate? Those bigger questions. What does it mean to have a great relationship? What does it mean to enjoy food? Those are the kind of questions that science doesn't answer, but the Christian faith does, and most faiths do. The reason I'm attracted to the Christian faith in particular is it actually is rooted in history. So unlike a theoretical or an abstract philosophical faith, it actually says God intersected the world in certain places and certain times, and here's how it actually happened. It's not God does this and the world runs this way. They actually meet. And because of that, you could actually measure the meeting. You can actually say, well, if Jesus lived, then here's what it should look like. If Jesus resurrected, then here's what it should look like. And that actually makes sense to me. The fact that I can actually measure through historical lens as to what's going on, that's attractive. The question I started asking maybe 5 to 10 years ago in a very serious way, which had echoes of it beforehand, was, what does it mean to be human? And if you start asking that question, I wanted to ask that question through the lens of a mathematician. What does it mean to be human as a mathematician? And so the Christian faith says actually that this world, though amazing and beautiful and gorgeous and attractive, is still broken. There are parts of it that just don't fit, and there are echoes of glory in the background. It's pointing to something more amazing than what we have right now. And so that more amazing world is the new heaven and the new earth, when things will all be set right. So being a mathematician, I got curious. What will math be like in the new heaven and the new earth, right? Like, how much of this math is going to last? Because you always want to make a lasting impact on whatever you do. And how much of the math is going to fade? And if it's going to fade, why am I spending time on that stuff? And if it's going to last, I want to spend a lot more energy there. So, true with any friendships we have, right? We have 1,000 friends, and out of that, we're going to pour our energies into just a few of them who become really close friends, because we want those friends to last throughout our lives. We can turn to them in the worst and the best of times. And so I wanted to know in mathematics what will last. And I came to the conclusion that everything does. That's the cool thing about math, is everything's going to last. The new world's going to take the mathematics we do, and you're going to see it in a much better way. But more importantly, though, this new world is going to be a physical world, just like this one. So in other words, it's not that the physical world, maybe as Buddhism or maybe Hinduism says, is kind of this temporary place where you can't wait to get out of it and to become disembodied and purely spirit. It's actually the physical world rocks. It's amazing. So in the new earth, this new heaven and the new earth where God and his people are going to be together, is a place where the physical world is going to be there, except you're going to see it the way it was meant to be seen. The photograph you hold in your hand will now become the real place. Instead of a photograph of the Grand Canyon, you're going to be at the Grand Canyon. It's going to be amazing. And so how can we make that come to the world today? How can we make the future be like that in the world today? And so what I wanted to start asking is, how do you make math physical? That's the question I really wanted to ask. If the new world's going to be physical, how's math physical? It turns out, if you think about the academic life, academia is the most ivory tower of every discipline, right? You could be a plumber, a carpenter, you could be a CEO, you can be a data analyst, at least touching the keyboard, knocking away. But an academic is like sitting, literally thinking, without actually interacting. There's this notion of just literally thinking in the ivory tower about thoughts. And the most whitest of the white collar is a mathematician. Because a chemist is actually doing chemical things, and a physicist is doing physical things, and a linguist is thinking about literature over time and the change of words. But a mathematician, man, we're just in our thoughts, these abstract ideas. So what I want is, how do you make math physical? And I started working with artists over the years, because artists actually are deeply embedded in physical things. And I, as a mathematician who cares about shape, thought, man, who else but an artist who's thought about physical things and images to collaborate with? So I started working with artists that, we've done struggles with unsolved problems on spaces of trees and genetics. We have paintings that we did. Worked with artists in lots of different ways, but the most recent one that is kind of exciting is a collaborator and I, Diane Hoffus. She's another mathematician. She and I got together, formed a team of faculty and students and alum and community members, and we raised about $50,000, and we built a 2-ton sculpture that we took to Burning Man. And the sculpture is remarkable for several things. One, the outside of the sculpture is shaped like a dodecahedron, but the hinges of the pentagonal hinges open, and you can actually get in. And the outside looks like the Matrix iconography, where the lights kind of look like these matrix flow, which asks the question of what does it mean to be human in terms of a computer controlling you. And the inside, once you go inside the dodecahedron, it's lined with about 10-foot tall mirrors. It's a mirrored room of a dodecahedron. And it's basically reflecting you all around. So now all of a sudden you're absolutely human. You're not in this outside environment. And it asks the question, now that you've kind of gone past technology, what does it mean to be human in the middle of all this? So that's the artistic framework of how we thought of it. But in terms of the object itself, it turns out that a mirrored dodecahedron is a really close example of what our current shape of our universe could be. You know, the shape of the Earth is a sphere, but what's the shape of the universe? It turns out that the Poincare dodecahedral sphere, which is a version of the dodecahedron where you can kind of pass through walls and do these cool tricks, the mirror dodecahedron comes to scratch that itch of what the shape of our universe could be. So that's really cool. It's an unsolved problem of what the universe is. And also there's an unsolved math problem, which is, can you take any polyhedron and cut along the edges and unfold and lay it flat? So Albrecht Dürer, 500 years ago, asked this question. Is it true that any polyhedron can be laid flat by cutting along the edges? And it's still an unsolved problem today. It's the biggest unsolved problem in geometry that I know of. And so it turns out the dodecahedron actually unfolds, that you can get in just like the way Dürer imagined. And then you could fold back in and get into the shape of this universe. So it deals with these unsolved questions of mathematics, unsolved questions of physics and cosmology, and yet it's a physical object that people can interact with and think about what it means to be human. In terms of math as an evidence for my faith, I don't see it. So in other words, I could look at a beautiful theorem and I can say, wow, that's a gorgeous theorem. I could be an absolute atheist, not believe in anything beyond the world that I see in some sense, and say, this is pretty, right? The Gauss-Bonnet theorem is one of the prettiest theorems in the world, period. Or I can believe that there's a creator out there who designed the world and has partnered with us to create with him. And I could also look at the Gauss-Bonnet theorem and say, this is pretty, this is gorgeous. And I could just add the words, wow, thank God that he thought of these beautiful things and has allowed me to see his creation. So either way, Gauss-Bonnet is Gauss-Bonnet. And so this is just this external viewpoint of how I view the world, looking at mathematics. But the math itself I don't see it as a pointer to God. In other words, it is a pointer to God, but it's not enough to convince me. It's not enough to push my chips into the bucket of faith just because mathematics makes sense. Not for me. If I could have one dream, it would be two pieces of thread that would fit together nicely. And the first thread is to say we should be careful with the Enlightenment, which shatters our disciplines into pieces. And so some might be better than others. To say that math is better than the humanities, which could be better than the arts. I think we should value all of them and put it back as this tapestry. And the second part is to push back not just against the Enlightenment, but against the Industrial Revolution. To say that this mass production of things makes us better humans. I think we have to be really careful of what it means to live in a world that's physical. That as we think more about the digital world, that we become disembodied. We forget what is important to smell and touch, and we keep thinking data and the proliferation and the quantification of data is valuable. It is, but not compared to being human. A great cup of coffee is better than 1,000 data analysts and their code that they can write. A great conversation over a good meal made at home is more remarkable than climbing the highest tower you could imagine in New York. So as long as we value what it means to live a blue-collar life with those who use their hands well and honor them as much as those who might honor the white-collar world, and at the same time honor these different disciplines, I'd love it.